Good evening, everyone. Thanks for being here for the second webinar in the Targeted Grazing short course. This one is on wildfire fuels and landscape evaluation. My name is Katie Lowe. I am the statewide coordinator for the UC A&R Fire Network, and I'm based out of the Cooperative Extension Office in Auburn. And in addition to being the coordinator for the network, I also am a fire ecologist. I'm a forest ecologist. I do a little bit of research on targeted grazing. And before I begin, I want to give my co-host Kristen Shive the opportunity to introduce herself.
Sure. Hi, everybody. It's great to be here. Kristen Shive. I'm a forest and fuels extension specialist out of UC Berkeley, and I have a long background working in conservation and land management, primarily in forests and fuels and fire ecology in general. And as I will probably say many times during presentation, targeted grazing is not my expertise, but fuels are. And obviously there's a big intersection there. And so I'm excited to share a little bit about how fire ecologists think about fuels and fire regimes and how targeted grazing can fit into that kind of framework. So thanks for having me.
Thanks, Kristen. I think with that, we will go ahead and get started. So just providing a quick overview of what we'll cover during today's session. So on the screen here, you'll see our agenda for tonight's session. So Kristen will start us off with a basic lesson in fire science and fire history in California. Then I'll talk about the applicability of small ruminant targeted grazing and different ecosystems across the state. And then we have a hopefully thought-provoking interactive activity for the whole group to do. So overall, we really hope that you leave this session with a better understanding of fundamental fire science, ecology, and also the history of California's ecosystems, specifically the fire histories of these ecosystems. We also really hope that you understand the applicability of small ruminant targeted grazing as a fuel reduction tool in different ecosystems across the state. And then also we want you to start thinking about how land managers can work with targeted grazers into incorporating grazing into different types of land management plans. So with that, I will stop sharing and hand it over to Kristen.
Thank you, Katie. All right, let's see. Will I pull this off? It's always a crapshoot. There we go. I think you all can see my screen now.
Yep.
Great. Okay. So as I already mentioned, I am more of a forest and fuels person, but I think a lot about fuels in general. And I usually give this sort of basic fire ecology talk in close like 45 minutes to an hour. This is going to be abbreviated, but I hopefully will hit all the highlights. And one of the first things I want to just sort of do to set the stage is to get us thinking about how fires have been burning in California. So this graph, it is not current. It only goes from 1923 to 2023. And that's what you've got on the x-axis there. And then on the y-axis, you have acres burned. And as you can see, of course, there's always been variability related to ignitions and particularly climate. But as time goes by, we do start seeing more fire, and particularly in the last couple of decades. And I think we've all just felt this in our daily lives, right? 2020 in particular was our banner year, was by far the biggest fire year on record. We had a little over 4 million acres burned. And I think for a lot of us, it was a really kind of a shocking year. There was so much smoke, I think, sucking out most of our communities. But of course, if we go back in time and look at estimates from like the pre-fire exclusion era, so prior to say 1880, 1850, that's about how much area burned in California historically. So the area burned isn't so much the problem, but of course, as I'm sure most of you are familiar, a lot has changed. We have one of the biggest things, honestly, is just more people and infrastructure that are intermixed in wildland areas, sort of in the WUI. The changing climate is playing a big role. Legacy of past land use. We have a lot of areas, particularly in forests, that maybe were clear cut and have come back as very dense, even age stands. And as a result of all of these things, we've had big changes in fire severity. So I'm really just going to hit two big topics tonight. The first is just the fire ecology basics, as Katie mentioned. And then I'm also going to talk a little bit about the role of fuels treatments, sort of writ large, before Katie kind of zooms us in a little bit closer on targeted grazing as the fuel treatment. So when we think about vegetation types and history of fire in California, the vegetation type is hugely important, right? So each vegetation type has this unique historical relationship to fire. And what I'm showing here, this is a very general map, just going kind of conifer forest, grassland, chaparral, oak woodland, etc. And that historic relationship to fire is really described by what we call a fire regime. I want to point out, though, that it's much more nuanced than that because even just within the conifer forest types, there's a ton of diversity and there's some slight nuance in the relationship to fire within those. So it can be pretty complex and complicated, but we're going to approach this in a very sort of high level, sort of big vegetation types to talk about major themes in California's sort of fire regimes and fire history. And so when fire ecologists think about fire regimes, we think about specifically about like maybe five major attributes, seven, depends kind of how you want to define it. But one is sort of the spatial complexity of how it burns, the size of the fires, and this is all historically when they would have been primarily natural burning or indigenous burning, basically prior to exclusion. Seasonality of the fires, that's easy in California. They're pretty much all summer and fall, but if you were in Florida, they're actually winter. And then the frequency of the fires historically and the severity. And really understanding historic fire regimes is super key to help us understand when a modern wildfire is good, quote unquote, for ecosystems or bad for ecosystems. And it also helps us understand what types of restoration treatments or fuel reduction treatments we might target, right? Like what are those species adapted to? And in particular, by far the most important concepts here are the concepts of frequency and severity, and they're super tightly linked. So I want to define for you how we think about fire severity. And again, I'm giving a lot of forest ecosystem examples, but this applies kind of basically the same in other systems. And severity is a gradient. When what we think of with severity is how much live vegetation is killed. And while it's a gradient, we tend to lump it into these three classes. So a low severity fire would be sort of that less than 25% mortality. This is a picture from a prescribed burn, but the idea would have been the same historically. You get the fire burning on the forest floor, not killing much of the overstory trees, but consuming more of your sort of smaller brush and small trees, herbaceous layer, etc. The moderate severity, it kind of becomes a big catch-all, but this is where fire starts sort of transitions into the treetops, or if you're in a chaparral system, getting up into the crowns, and can result in anywhere from 25 to 75% mortality. It tends to be really pretty patchy. And then high severity is areas where you get more than 75% mortality and pretty often, honestly, 100% mortality. We're seeing more and more over large contiguous areas. So really, this is just describing how much vegetation change you get after fire. And when we think about the controls on fire severity, I want to introduce you all to the fire behavior triangle. So this is essentially like what every firefighter learns during their first training classes. And that's that the degree of fire severity really depends on three things. Topography, so how steep your slopes are. Steeper slopes burn hotter. There's a bunch of reasons for that we won't get into. Weather, I think it's pretty intuitive that when it's hotter and drier, you're going to get the fuels are much more available and you're going to get a much more severe fire. And then the fuels themselves. And I'm going to dive into these for a minute because they're really, this is really kind of the key, obviously, overlap with targeted grazing. And it looks like there we go. Had a weird cue there. Anyway, so these are the four considerations that I think are the main points you need to think about fuels, right? So what's the fire type or sorry, fuel type, and specifically which type is the primary carrier of the fire? What is the amount, continuity, and arrangement? And so with fuel types, we tend to lump them kind of really generally. Like you might look at this and see forest type, but it's really the forest litter. That's the primary carrier of the fire. So all the debris on the forest floor. If you were in a hardwood system, it would be all the hardwood leaves on the forest floor. Shrubs themselves, in shrubland systems, they can be the primary carrier of fire. And then in grasslands, grasses are going to be your primary carrier of fire. But that important point where I said which fuel type is the primary carrier, that's really critical because in oak woodland, a woodland is a type of forest, but if it's open and it has a really, dense grass understory, it's actually the grass that's your carrier of fire. It's not the trees. And that can happen even in conifer forests. We have many that have a substantial enough understory that that's your considered your carrier. Fuel amount is kind of obvious. So this is just a pre-post picture of some thinning that was done in Merced Grove and Yosemite. So just the sheer amount of fuel is important, where, the fuel is both live vegetation and the dead woody debris. And then fuel continuity. So we think about fuel continuity in sort of two dimensions, but broadly you can imagine it's just where you're getting connection between different fuels, right? And so when you can have vertical continuity, and in this example, you have your overstory trees on top and some little trees on the bottom, but there's a nice gap in there which could allow fire to move through the stand without getting into the canopy. We also then, but you could have very high vertical continuity, and that's what you see in this other schematic where you're starting to get a tighter linkage between the fuels so fire can transition more easily up into, say, the canopy. There's also horizontal continuity. So in these that are we've already shown here, you can see if you just look at what are the mature trees or cartoon trees, you can see that they all the crowns are touching. So that's really high horizontal continuity. But if you open that stand up from the overstory standpoint, you have much lower horizontal continuity. Um, and you can also have low horizontal continuity with still high vertical, right? So the point here is not to go too far into the weeds on exactly, but you can see that the different configurations of continuity can really matter depending on your forest type. And then also fuel arrangement, which is related to continuity. But when we talk about fuel arrangement, we're mostly talking about sort of the different strata of fuels. So you have ground fuels or surface fuels, which in the forest case is woody debris and grasses. It's the grass themselves, the thatch. You can get these ladder fuels, and that's again what can help transition to the overstory. And then aerial fuels, which is the tree crowns, which we don't manipulate as much from a fuel standpoint. Okay, so just to remind you, we kind of did that deep dive on fuels just because of its importance in relation to fire severity. And if we go back to that basic fire regime relationship with that frequency severity link, in general, a high frequency fire regime, such as if, this was a prescribed burn from Yosemite, but you can imagine if this fire came through once every 10 years or so, it would keep the grasses, herbaceous layer, small shrubs, and trees down. And because the fires were frequent, there's less fuel accumulation between fires, generally a low severity system, right? And so that's a really good segue to a sort of a prime example of this type of fire regime is the mixed conifer forest of the Sierra Nevada, but it applies to many of the conifer forests throughout California. I think these are always just kind of neat to look at. So this is a cross section of a tree. And as you all know, I'm sure trees put on annual growth rings, and dendrochronologists who are much smarter than me are able to date those. They can cross-reference with regional chronologies. And these arrows you see are all pointing to areas where there's been a fire scar. So this is one of the ways that we understand just how frequent fires were prior to the fire exclusion era. And then what people do is they take each one of these, and again, don't get too worried about this. This is just, I think, kind of a fun fact more than anything. You've got on the x-axis there, you've got the year, and then all of those horizontal lines going across are individual trees, and the vertical notches are fire scars. And so you can see that there are years where it really lines up that there was a lot of fire. And so that's a year of more widespread fire, and the other years it was maybe a little bit more patchy. And so, as you've probably already guessed, those mixed conifer forests have that predominantly low to moderate severity fire regime with small patches of high severity because spatial pattern, it really matters, right? No, none of these, when I talk about these systems, no system was uniformly one or the other. And in fact, I think, if you ignore the high severity, then there's a lot of habitats in the Sierran forests that there are a lot of wildlife, I should say, in the Sierran forest that would lose habitat. We want a little bit of high severity, but we used to get a few tenths of an acre to maybe a few hundred acres, and now we're getting thousands and thousands of contiguous acres. So it's really that spatial pattern that matters. And in our mixed conifer forests, and it reduced fuels, regenerating trees and shrubs. It promoted regeneration of fire-adapted trees, recycled nutrients, promotes plant diversity. Particularly those last two are really important in grasslands as well. But as we move into sort of the modern fire regime, getting back to our fuels, that's really what's changed. And when European Americans came to save the forest, and they started putting out all lightning strikes and also started suppressing indigenous burning. The dates aren't on here, that's my error, but on the left hand side you see it's about 1890, I think, and that's Yosemite Valley, and you can see it's pretty darn open. And on the right it's, I think, in like the 1960s, and then that little inset is like sometime in like the 1990s. And you can see we've got having major densification of the forest in here, and this is a place where lightning didn't go, so this was all indigenous burning, right? And so by prohibiting that and suppressing lightning strikes, we've changed things dramatically. And of course, you all also probably know that we're getting warming temperatures. That's drying out our fuels. Don't need to dig into this graph, but you've probably seen many where over time we're getting warming temperatures compared to our averages, and that is consistently drying out the fuels. And we're getting these interacting stressors now, right? We have incredibly dense forests and fuel-loaded ecosystems with warming temperatures. And this is a particularly problematic combination for our forests. That's resulting in those increases of high severity fire that I was talking about. And this is a huge problem for watersheds, right? This is an area in the 2014 King Fire. You can get a ton of erosion, and that's really problematic for water supplies since most of our water comes from the Sierra Nevada. But that's also a huge problem for homes and communities nearby, of course, and there's been a tragic amount of home loss and life loss in recent years. And when we shift to grassland and woodlands, they're very different ecosystems, and yet they're very similar in that we think they had frequent lower severity fire to keep them open, particularly like these open oak woodlands. In grasslands, so the consequences of fire exclusion, sorry, I should back up and say the consequences of fire exclusion are somewhat different than they are in the Sierra, but they both result in an alteration in the overall fuels and vegetation structure. And so in terms of a true grassland, you start to get shrub encroachment without regular fire in many of them. And in oak woodlands, you can sort of transition to a more closed canopy hardwood forest. And so you need some sort of disturbance, fire historically, to keep these ecosystems kind of in the state that they're in, for example, like you see here. So now to shift gears, and again, remember, I'm giving you sort of I'm giving you examples that are sort of ends of the spectrum, but there is a lot of nuance in between. And so we also have these predominantly high severity fire regime where high severity was not necessarily a bad thing, right? So coastal chaparral is the most classic example. The fires were very low frequency. That gave a lot more time for fuel accumulation between fires, both amount and continuity. And that led to predominantly higher severity fires. And, specifically, we think they burn on the order of every 30 to 100 years, depending on where you were. And part of that is because it's very coastal and there's just a lack of lightning ignition. So if you were near to an indigenous settlement, there may have been more fire, but further away, there just wasn't the ignition source. And it's often pretty much a little bit cooler and wetter, right? So you get that accumulating dense vegetation, and that leads to that high severity crown fire. But they are really adapted to it. Most of the species sprout, and or they have seeds that can live in the soil for a really long time in seed bank, and they get a fire cued germination, meaning they need that hot fire to germinate. So in that sense, fire exclusion hasn't had such a negative impact since they had infrequent fire anyway. It's not quite that same story as the Sierra Nevada. And we talk in a minute about fuels management. That's going to get really important. So it's sort of like, what are your goals with fuels management? Are you trying to restore to some specific structure? Does it need less fuel? And inherently, chaparral doesn't always need less fuel. This is not such a inconsistent state. Having said that, the problem down there is actually, particularly in Southern California, is that they're actually now getting too much fire. So we have, a lot of non-native grass invasions, which can help. That's that add fuel continuity, and that'll come in right after like an initial fire. And then we also have increased ignitions just by the sheer population density near the coast and throughout Southern California. And that can be a real problem because it limits the seed production for future recolonization. And so maybe you get a flush of new growth and you get some, some plants coming from seed and you get some shrubs sprouting back. But if they reburn before they can basically create more seed for the future, then you're going to sort of run out of that seed bank. And we're going to start seeing conversions here to non-native grasslands potentially. Okay, so with that lens of sort of needing to think about what are the species adapted to? What was that historic fire regime that shaped them? And then how we think about managing our vegetation now, then we automatically have to intersect that with just simply thinking about fire risk to communities and infrastructure and other areas. And so I want to start really big picture, which is what is the role of fuel reduction treatments? And that probably seems like a no-brainer, but I think sometimes we get it there's a little bit of nuance that we're not always thinking about. And the first and most important is that they're not just intended to stop a fire on their own, even linear fuel breaks. Instead, the goal is to either, particularly when it's done at a landscape level, reduce fire severity. So this is a classic picture, and I forgot to put the credit, but I believe it comes from someone in the Karuk tribe. But you can see a wildfire came through here. There's an area with thinning only. Some of the trees survived, but a lot were killed. An area that had thinning prescribed fire, you have an intact green forest, and an area with no treatment, and you pretty much lost the trees. So that's one of the key roles of a fuel treatment. But the other thing is in giving firefighters a safe space to engage the fire. That's just absolutely critical. Fire's not just going to come to that, fuel break and stop, but it can give people a place where they're comfortable working. And so this picture actually comes from my co-host Katie Lowe, put out a really neat paper a couple years ago about the role of some fuel breaks in the Northern Sierra. And if you look, at that picture that's pre-treatment from 2001, there's a lot of dense fuel there. There's a lot of ladder fuels. There's also a lot of woody debris in the forest floor. It's a little bit hard to see in that older picture. But then if you look at that 5 years post-treatment, that's after it had a thin and a prescribed fire, and I think actually a wildfire. But you can see how much more open it is. And that is just a place that firefighters are more likely to be willing to go in and engage the fire rather than when it's roaring through really dense fuels. And so we think about, again, as sort of as ecologists and as vegetation managers, we think about fuel reduction in two ways. One is that fire is obviously the most critical. That's what these ecosystems evolved with, but that we can also use fire surrogates. And so when we talk about fire as a tool, we're primarily talking about prescribed fire. So that would be like broadcast burning. So people out there with drip torches. It can also include pile burns. So you might cut and pile a lot of your debris. And then there's also fire surrogates. So that would be mechanical thinning, mastication, and why you are all here, targeted grazing. And each of these tools target different fuel strata and arrangement, and I think they're each just appropriate for different situations. I am a really big believer in all tools in the toolbox and right place, right time, right? And so what I want to end before I shift over to Katie to talk about a little bit, to hone a little bit more on how this all links in with choices of where and when to use prescribed or targeted grazing. I just wanted to make a note on this idea of fuels reduction versus restoration, because they're not always the same. And so really broadly, one of the ways that we think about it is that fuel reduction, the goal is to reduce severe fire and allow firefighters to engage a fire, as I already said. And those tactics are strictly focused on reducing total fuel amount and continuity. And honestly, it's not really related to whether it isn't relevant whether or not that's what's best for the ecosystem, because this is something you're going to do outside a community either way. But it's really nice when it also aligns with restoration, which in many ecosystems in California it does. And so in this kind of process, you are also doing the things in many situations that are that you're doing with fuel reduction. But the goal is more to promote fire as a process and sort of to reintroduce that disturbance agent, hopefully fire, but sometimes you use another tool, and sometimes you use that other tool so that when fire comes, it can burn. So sometimes you might thin or do some targeted grazing first and then apply fire. And feel more confident in being able to continue to apply fire. And the tactics are a little bit more focused on things like restoring structural attributes, and you put a lot more consideration in terms of like landscape context. Um, Again, there's a ton of overlap, but they don't always align. And so you can imagine, particularly in, say, chaparral systems, they may not need that regular treatment every year or two ecologically. That could almost be kind of damaging. But in that small band around a community, you might decide to do that anyway because you need to sort of reduce that fuel adjacency, right? But in the mixed conifer and the Sierra, generally fuels reduction do align really well with ecological restoration. And so with that, I am going to stop and hand it over to Katie.
Thanks, Kristen. I think we have time if folks have any questions for Kristen before we transition. I think it's a small enough group you can unmute yourself and ask.
I have a question for you, Kristen. And you kind of touched on this already, um, but removing fuel is not the only fuels treatment, right? Rearranging fuel continuity and rearranging the fuel bed. Is there some ways that we can think of using grazing in that regard beyond just what the animals eat that could be helpful as well?
Yeah, I think so. And I think that's actually something that Katie is going to cover in her section. So that was kind of how we split up. So I won't steal her thunder on that one. But I do think, yeah, thinking about all three of, all of those components of fuel, like you said, it's not just amount, but also that configuration is huge. And I think in a lot of ways, grazers can do that in a way that's different from our other tools.
Any other questions? Well, if not, Kristen will be here until the end of the webinar, so feel free to pop those questions in the chat. Now we'll just transition to my presentation. So that was a wonderful overview of the fundamentals of fire science and ecology and fire history in California. So thank you, Kristen. And so now I'm going to transition to talk more about the applicability of targeted grazing, in particular small ruminant targeted grazing. So it's no secret that well-managed grazing can be really beneficial in reducing live fuel loads and wildfire risk, also all while maintaining and enhancing ecosystems, but rangelands in particular. And although grazing can really provide us with a lot of positive outcomes, it, as Kristen said, might not always be the appropriate fuel or vegetation management tool for all ecosystems in the state. So in this next section, we're just going to talk about where we can use grazing in California's landscapes and talk through ways that you as grazers or practitioners um, can go to project assessments or bids and start to think about how you can effectively deliver treatments. So historically, across many ecosystems, the introduction of livestock species from Euro-American settlers really altered plant communities, fuel loads, and therefore fire behavior. Grazing has really impacted fire activity in California for many years here. So up until widespread fire suppression policies were implemented into the 1900s, many ranchers used fire as a tool to better promote forage quality in pastures after they were grazed. Um, Farmers used it as well. So grazing communities and practitioners still integrated fire somewhat into their practices. But again, up until that fire suppression period, like Kristen mentioned, um, or afterwards, fire was really excluded and suppressed from a lot of the landscapes. And so I believe that this was covered last week, but again, just want to briefly touch on the difference between commercial livestock grazing and targeted grazing here. So our rangelands in California have a long history of commercial grazing where animals are raised for profit or subsistence. Commercial grazing on our annual rangelands is done typically from late fall through late spring, and this is typically when forage species are more nutritious and abundant for animals. And although commercial livestock production is typically more focused on animal production and not primarily on fuel reduction, you do have an added benefit in significant reduction of fine fuels where there is commercial grazing. So on the other hand, targeted grazing is used to achieve more specific vegetation management objectives, such as fuel reduction or weed management. And in this case, actually, animal production objectives are secondary. So with these differences in mind, let's talk a little bit more about how grazing can be used as a fuel management tool. So Kristen did a great job reviewing the different types of fuel treatments and how they're commonly used or different fuel types. I'm just going to expand upon those a little bit further. So when it comes to fuel treatments, we can lump them into two broad categories. There are treatments that rearrange fuels and treatments that reduce fuels. So treatments like mastication and chipping, those arrange fuels or rearrange fuels, excuse me, on the landscape. So they tend to take those smaller live trees or shrubs and they convert them into smaller dead woody fuel particles. And really, until those fuel particles decompose, that fuel really remains on site and just in a different form. And so the only two treatments that really reduce and remove fuels in systems are prescribed fire, pile burning, and grazing treatments. And so while prescribed fire, like Kristen said, can both reduce downed woody fuels and live fuels, grazing treatments, unfortunately, can only reduce live fine fuels. So here on the screen, you can see two images of environments where grazing can be used. The one on the left has both an herbaceous and woody fuel component, and the one on the right, though it's more zoomed out, it likely has less woody fuels than in the mixed conifer forest on the left. So grazing can reduce fuels in both of these systems, right? But in the system on the left, small ruminants can only do so much, and you'd likely have to couple that with other treatments like we'll discuss later. And so I think it's really important. I think Morgan said this to me once, the livestock producer, or as a livestock producer, it's really your job and responsibility to evaluate the type of vegetation and the vegetation management objectives. And from there, you can choose the best type of livestock, the amount of animals you have, and also the timing of your treatments to really achieve your objectives here. So now we're going to briefly go through the different types of ecosystems Kristen brought up and talk about the potential use of grazing within them. So small ruminant grazing can be really effective for reducing fuels in grasslands. Generally, grazing can be used to reduce the amount of fuel and also the height of fine fuels in smaller shrubs in these systems. So breaking up reducing the overall fuel load, like Kristen talked about, and then also potentially impacting continuity of fuels, like she talked about as well. Animals, of course, can also help create more compact fuel beds through trampling. And though we didn't have time to go into it in the earlier section, a more compact fuel bed also could be more harder to ignite or just because there's less oxygen drying out the fuel particles. So in many of California's grasslands, though, unfortunately, maybe you're familiar with, they've been taken over by non-native plants, which can produce high level of fine fuels, which are very flammable. Of course, wildfire can move really quickly through stands of these non-native flammable plants and carry fire to nearby woody fuels. Shrubs that also can invade grasslands can also burn hotter and for longer periods of time than grass if they're ignited. But, in these systems, we can use grazing to alter fire behavior and provide firefighters with safe places to conduct their suppression activities. But I want to hammer home the point that in this system, again, like Kristen said, grazing will not reduce the source of ignitions, and it also will not really reduce the spread of fires in these systems because, again, the main fuel carrying the fire is grasslands or grass, excuse me. In these systems, goats and sheep, they can effectively also consume more invasive species, which can help with restoration, which is great. And in some cases, the careful application of small ruminant targeted grazing can actually increase biodiversity, though overgrazing can lead to decreases in biodiversity. So it's all about the careful use and application. And of course, in terms of treatment maintenance, all fuel treatments, regardless of their type, I say this all the time, will need to be maintained at some point. So in this case, due to the life cycle of grassland species, grazing treatments probably will need to be applied in shorter time intervals, like annually, for example, in order for treatments to maintain their efficacy in reducing fire behavior. And this is particularly true for treatments that are implemented near human communities. And I feel like in the foothills where I live and work, this is a very common thing that you see in the late spring, early summer is the animals up in the hillsides grazing grass near communities. That's every year. So moving on to oak woodlands, grazing can also be an effective tool for reducing fuels in these systems too. They can, again, reduce the amount and the height of fine fuels and smaller shrubs, and they can also potentially impact smaller sized trees that can act as ladder fuels that Kristen brought up. So similarly here, they also can create more compact fuel beds, particularly if if the woodlands have this grass understory. And through reducing surface and ladder fuels, these treatments can reduce fire intensity or the heat or the energy produced by a fire, can slow the rate of spread, and it can also reduce flame lengths. But I'd say the real benefit of implementing grazing in oak woodlands from a fuel management perspective is the ability for small ruminants to target some shrubs and smaller trees if they exist in these systems, which can act as ladder fuels. Remember, they are responsible for bringing fire from the surface up into the canopy of our large oaks in this case. And generally, once fires get into the canopy, they're a lot harder to suppress. In these systems, grazing can be used to really alter fire behavior in the understory. And they can provide first responders with safe places to conduct suppression. Again, in the system, though, grazing does not reduce the risk of ignitions or spread. And then also, grazing does not address the densities or continuity of larger overstory trees. So we can't really do anything about larger fuel continuities like Kristen shared that can really drive or impact fire behavior in a system like this. And here also, again, goats and sheep can effectively consume an invasive species and promote biodiversity if grazing is carefully applied. And really, depending on the species in the understory and the density of your oak woodland, grazing treatments may need to be applied in shorter time intervals in order for treatments to maintain their efficacy. But also, grazing may need to be followed up by other treatments like prescribed fires or thinning treatments to target the removal of ladder fuels and woody fuels, especially in denser oak woodlands. Now we move into shrublands. Small ruminant grazing here can have varied effects when it comes to reducing fuels in shrublands. As Kristen alluded to in her presentation, shrublands and chaparral are a little bit different and unique in their fuel and vegetation management challenges. So grazing can be used to reduce some amounts of fine fuels in smaller shrubs in these systems. But really, the main carrier of fuels in a lot of these established shrublands are either larger dead woody fuels or larger, more established shrubs, which again, small ruminant grazing doesn't as effectively target or reduce the volumes of those fuels. And again, similar to all these other ecosystems, right? Grazing does not reduce the risk of ignitions or fire spread in these systems. And really, especially for folks down in Southern California and those shrublands, ignitions is a really big problem. Increase in frequency of ignitions is a big problem down there. So In most cases, in these systems too, just a single grazing treatment is not going to be effective in eliminating undesirable species. So for some shrub species, you may need to implement multi-year intense treatments to kill or damage, significantly damage the root stock for stubborn species. So in terms of maintaining treatments, it's important to understand that many brush species, they'll resprout pretty significantly, potentially following grazing, and they'll have to be retreated again in subsequent years with other tools potentially, um, or through repeated grazing to achieve longer term impacts. But as Kristen pointed out in her presentation, um, the goal of fuel reduction in chaparral and shrublands may not align with the ecological restoration objectives of these systems. And so maybe in areas where you are grazing closer to human communities, you may be asked to graze more frequently. And then maybe these systems are used to from a disturbance standpoint. So now moving on to conifer forests, there is really limited information about the applicability of small ruminant grazing in our conifer forests, unfortunately. Um, Even though it's well established in rangelands, it's really been understudied so far in forests, but some of us on the call are working on it currently. So there is greater interest, though, in using grazing in some conifer forest systems, particularly around communities in the wildland-urban interface or intermix, to reduce densities of understory shrubs and plants. And then also, Kristen mentioned there's been a increase in recent decades in high severity wildfire. That unfortunately has led to the creation of large patches of shrubs that historically did not exist in these systems. And so people are turning to grazing also in a post-fire context to reduce the amount of shrub cover post-fire. So grazing can be used to reduce, again, the amount and the height of fine fuels in smaller shrubs in these systems. And again, they could also potentially impact smaller sized trees that can act as ladder fuels. They can also, however, sorry, they do not address woody fuel loads or the continuity of larger overstory trees, which is really can be the primary driver fuel type in these conifer forest ecosystems. So that is a limitation of grazing here. And though, again, grazing treatments, they can reduce life surface and ladder fuels, they can alter fire intensity, they can slow the rate of spread and reduce flame lengths. Due to those complex fuel profiles that exist, so different strata, as you can see here in this picture, grazing is likely not the only tool that should be used to reduce fuel loads in this context. In fact, many of our overgrown forests in the state, it's more appropriate or a more appropriate and effective way to use grazing and fuel management plans would be to thin out the overstory and remove some of the more decadent brush in the understory, and then follow that up with maybe a prescribed fire to reduce some of the understory plants and also take care of the woody fuel loads. And then you could bring in grazing as the third touch treatment to help really maintain more open stand conditions by periodically coming in and grazing the shrubs that are regrowing. And of course, it's really important to understand the benefits and the costs of using grazing when removing wildland fuels, and to understand that in most circumstances, again, a single grazing treatment will not eliminate your undesirable species in the same way as other treatments like herbicide or mechanical means will. So it's important to understand that in these systems in conifer forests, a lot of the plants that small ruminants will be asked to treat tend to prolifically resprout following grazing treatments, and they will have to be treated in subsequent years with either other tools that will more aggressively impact the plant or through repeat grazing. Yeah, Morgan?
Yeah, Katie, just a question, specifically in regard to that situation you have in the picture there.
Mhm.
Um, have you seen some instances where grazing has been used as like an initial fuel treatment just to open up the landscape a bit, the lower canopy, just to provide access for people? Have you seen that, or is that effective?
That's a great question. I personally have not observed that, and maybe Dan has. I will say, so this picture is taken from a mixed conifer forest in El Dorado County called Blodgett Forest Research Station, where Dan,
Mhm.
Dr. Bush, and myself and others are currently applying some small ruminant targeted grazing. And a lot of our study sites kind of look like this, maybe with more smaller trees. And we've been thinking about if we can use the animals to manipulate enough understory fuel to allow for the more safer application of like prescribed fire afterwards. So that's something that we're
Mhm.
definitely thinking about. And maybe I'll follow up with you in like 2 years when we actually do the treatment. I don't know, Dan, if you have anything else to add there.
I think that's a great question, Morgan. I've seen some other projects where people have gone in to pretty decadent shrub stands just as a way to get them opened up so they can get hand crews in,
Yeah.
actually see. And I think
Okay.
one of the things that we were finding anecdotally at Blodgett is the plots that we have grazed are infinitely easier to walk through today than the ones that have not been grazed since the fire, that have grown
Hmm.
for 3 seasons. And if you really want fun, we'd invite you to come help us find plot centers in the ungrazed plots next year because it's a great way to get ticks and look for mountain lions.
Is that an invitation to me or to everyone?
To everybody.
Everyone but you in
Okay, good,
particular,
good.
Yeah. Yeah. Hopefully no ticks, hopefully no mountain lions. So, uh, but great question, Morgan. Thanks. Okay, let me see. Since we're paused for questions. Any questions in the chat that I should address, Dan or Kristen?
I think you're
Okay.
good.
Okay. Awesome. Sorry. Aren't I? Okay. So, ultimately, you as a livestock producer, maybe I'm preaching to the choir a little bit here, but you'll have to evaluate the type of vegetation and your objectives to choose, again, the best type of animal, the number of animals that you bring to each project, and the timing of treatments to achieve both I guess, the landowner's management objectives in this case. But here, I bring this stuff up, and maybe I'm veering a little bit into other folks' lanes, but I really do think, vegetation and fuel type can really influence other elements more on the business side of grazing contracts. That you must consider. So some of these things include the timing of your treatments, the animals that are right for the job, additional site-specific characteristics like terrain and other fuels on site, different costs associated with the project or the desired prescription from the landowner, and the potential impacts to your animals. So I also am not an animal person. I'm relatively new to targeted grazing, but like Kristen, my expertise is more in fuel management, and forest management. But through my own experience, helping design and apply targeted grazing projects with Dan, Dr. Bush, and others, I've really learned a lot, and it's come to my attention that it is important for grazers and landowners to consider how vegetation can influence other aspects of your grazing operations, especially when you're doing those initial assessments of sites or going out to bids. So I'm going to briefly cover some of these considerations, but they will definitely be covered by many experts in later topic or courses. So in terms of timing, um, the timing of grazing treatments can impact plant species composition and also treatment outcomes. So some plants, they tend to be more palatable and preferentially selected by animals at different times of the year. And generally, most of our plants have certain times of the year where they're more susceptible or resistant to grazing. So for example, grazing in the fall or winter, um, in terms of goats, they can reduce dormant and dry vegetation, which can decrease fuel loads and overall continuity, which is what we want. However, some areas, they might not be as accessible during all parts of the year due to snow or other weather-related obstacles. Grazing in the spring can be good for targeting more young, tender plants, particularly with our shrubs, like you can see here in this picture. And it also tends to be a good time for livestock weight gain, and as grasses and forbs are maybe more nutritious in different ecosystems. But during the late spring, livestock, they'll tend to graze forbs and perennial grasses that will stay green for longer than the annual grasses. Um, I wanted to note, though, that though grazing tender young plants is great, and they can help injure maybe more established plants or plants that are just starting to get established, grazing too early in the spring can actually encourage regrowth of targeted plant species within the same growing season, which from a fuel reduction standpoint is not good. And we learned that, I think, the hard way in our grazing project. And then finally, summer grazing can be used both to target both live and dead fuels. Ruminants, they can be used to target more fire-prone invasive species like Scotch broom, thistle, and cheatgrass, which can dominate areas during the summertime. Um, but in some ecosystems, the summertime also tends to be a period when your forage values may decrease, and so you might need to supplement animal nutrition to maintain their well-being. Again, that'll be covered later in a different course. As I mentioned earlier, treatment objectives will drive a lot of your decisions around when grazing treatments will be implemented. But if the majority of your grazing projects are aiming to reduce fuel loads and overall fire risk, then it's likely that the bulk of the contracts will be in the late spring to summer, because that's when grazing is most effective generally at reducing fuel loads. So when it comes to evaluating landscapes for treatment, we also want to think about what animal may be right for the job. So animal selection is really dependent on your management goals and the type of vegetation that their animals are expected to consume. I learned that this is really cool. Sheep and cattle, they're more effective at consuming more herbaceous vegetation on flatter slopes, while goats are more effective at consuming brush and operating on more steeper slopes. And also something that was interesting to me was livestock with more experience and familiarity with the site and the vegetation will be more effective at reducing fuels than livestock that are more naive or newer. And I learned this again through our own project at Blodgett. As you can see here, these are two different woody shrub species that are commonly found in the Sierra Nevada. When we stuck goats and sheep on these same sites and compared the difference between the two, the sheep were more effective at eating the deer brush, which is the plant on the bottom, because it was a more low-growing, tender plant. But on the other hand, the goats did a better job of consuming whitethorn, which is the thorny plant on the top. Even though the plant had a lot of thorns and less tender leafy material, they did a better job than sheep because of the way that they browsed. And we also found that the first time we did these experiments, it was a lot of the animals' first times grazing in these systems. So there was a lot of learning going on how to consume these plants. But the second season of grazing, some of the animals had more experience, so they ended up being able to teach the others, and that resulted in better consumption. Also, effectiveness will vary by site, depending on conditions like terrain, existing vegetation, and fuels. So you might be asked to graze on steep, brushy areas or in burned areas with huge burn piles in the middle of paddocks. So as you may recall, grazing treatments do not reduce the volume of downwoody fuels, and in some cases, this could be the primary fuel type that carries fire in the ecosystem. So maybe you need to work with the landowner beforehand to see if there's an initial mechanical treatment that needs to be done or burn to take care of those fuels, so you can either help move the animals around, like there's too many downwoody fuels and it's hard for the herder and the animals to get around, or that way they're able to achieve their fuel management objectives. And then also you want to consider additional equipment and supplies needed for projects. New projects may bring unforeseen costs, like being asked to graze in more remote areas with lack of access to water or in areas with more predators. Um, Another example could be that your animals are asked to graze in really dense shrublands where it can be hard to set up fences. So you might need to buy things like chainsaws or have folks cut through the brush in order to set up fences, that sort of thing. And then also you might want to consider how vegetation can impact animal production. So again, though production objectives are secondary to grazing, you still want to be mindful of the impacts that the plants and the vegetation can have on the health and welfare of the animals, because that can ultimately impact their ability to complete the treatments. Um, and so some examples or ways that vegetation can impact animal production include potential toxins or introducing potential toxins into their system, and the need for maybe applying different nutrient supplements to maintain their animal health. And again, toxic plants will be covered way more in depth later down the line, but I bring this up as an example, a real world example, because this was a lesson for me as someone who's approaching it from more of the land management side. So when grazing in new environments, it's best practice to consult with the landowner or your local cooperative extension livestock advisor to ask about potential toxic plants in the area. But you could always do your own research, and this resource on the screen, the livestock poisoning plants of California, is a great place to start. But I learned this lesson the hard way. Our research team, when we were originally designing our grazing units, we had them go through some more riparian areas. And that's where the landowner, the forest manager, really identified they wanted these areas to be treated to reduce fuel hazard risk. And we didn't know this, but these areas had a strong Western azalea component, and we didn't know that azalea is actually toxic to animals. So, unfortunately, after some incidents with the animals, we had to talk with the grazer and the landowner, and it was ultimately decided that though fuel reduction objectives are important in this case, they weren't as important as the health of the animals. So, it's really important that you do your homework and you can negotiate maybe with the landowner who may not be knowledgeable about toxins, but get them to understand maybe why the vegetation is not suitable for grazing treatment at this time. So lastly, I want to end on this fun slide. So really effective fuel reduction with grazing is best achieved when integrated into the ecosystem to manage surface fuel and vegetation competition or composition. And for a lot of California's ecosystems and where you'll be asked to work, you really need an integrated management approach that includes targeted grazing, but also that incorporates those other tools in the toolbox, like prescribed fire, like thinning, that can really be used to meet more complex fuel management objectives. So I'd like to think, like in my ideal world, the image that you see on the screen is like the best case scenario. I wish I could give the animals a drip torch after they're done grazing, and um, they would be able to treat all the acres that they ate, but that is not the case. That's up to us to do. So I will leave you with these last key points. So remember, when you are initially assessing your landscapes for potential treatment, first think about what fuels you're trying to target. So call back to that knowledge that Kristen provided you. How would you characterize the fuels on the area? What's their strata? What's their type? Are they very continuous, vertically or horizontally, that sort of thing? And then also draw from your knowledge of animal behavior and browsing preferences. So is a grazing treatment the best treatment for this system to reduce fuels given the fuel type? And then what animals are needed to meet treatment objectives? And then the last thing is if it isn't clear if grazing is the most appropriate treatment for this place at a particular time, what other tools could we use to get the landscape to a point where we could implement grazing? So with that, I think that is the end of my presentation, and we will transition to a more interactive activity. But before that, maybe I'll pause for some questions.
Katie, I've got a question, but maybe a thought to share
Yeah,
first.
yeah.
One of the things that occurs to me is that, you talked about kind of commercial grazing or what we would call conventional grazing. And in our annual grasslands and oak woodlands, that is a way we can treat really large landscapes, particularly with cattle. And I think as we use targeted grazing with virtual fence technology and cows, it gives us some other opportunities to be a little more targeted. Um, my question for both of you is, given all of this great information on fuel types and matching animals to fuel types, is there something that we need to do a better job of in determining kind of strategically where on the landscape we can have the greatest impact? Are there areas where vegetation types overlap with risk that we ought to concentrate grazing, or is it too broad stroke to think we can do that?
That's a good question. Kristen, do you want to go first? I can.
Sure. I mean,
Yeah.
I just think that given the sort of the incidence of grasslands and WUI and communities, I just think that focusing on those assets at risk is probably the best option. And when we think about landscape scale with fuel reduction in general, there is sort of ideas, particularly in forests, that you only need to treat 30% of the watershed and you can overall reduce fire severity. But the two things there is I think we're increasingly thinking you just ideally we get the whole landscape into shape, right? But the other piece is that it doesn't matter if you overall reduce fire severity at a landscape scale if you lose the assets that you're really concerned about, right? And so I think where grazing is really aligned with restoration, you might have those ecological objectives, particularly with weeds, et cetera, but where we're just talking about it as a fuel reduction tool, I think, to my mind, I think the best use cases are really, near infrastructure and values at risk. And I have to say, whenever I ride my bike in the Berkeley Hills and I see the cute goats doing their job, I cheer them on. I'm excited that they're here. So, continuing to deploy them in those areas is probably a great use.
Yeah, I'd have to agree with that. Like, I feel like the public definitely has will favor seeing 100 goats going to work versus like two people burning near their house. So I think, and we know that grazing works really well in rangelands and woodlands, and so continuing to um, strategically apply treatments around communities and in those ecosystem types, I think is key. But I also think, Dan, like in our own research that we're working on, if we can get to a point where we can kind of narrow down best management practices for grazing in those
Mhm.
mixed conifer areas, I think that would be really
Mhm.
awesome. And that's a goal I know of our project. So to be
Yeah, and I think
continued.
kind of
Sorry.
linking the two comments you made together, Dan, when I think about like commercial grazing and think about a lot of cattle grazing in the mixed conifer, where there's allotments and Forest Service land, and in some areas can do a lot of good, particularly when you have those open grassy understories. But in a lot of areas, like some of the images I showed, where it is just fuel loaded and small
Mhm.
trees, that's
Yeah.
just not the tool. So just reiterating, as you well know, but
Yeah.
just sort of reiterating that like they need to be able to target the problematic fuel, right? And so that's why the like in one place, one animal can do great things, and another place it's probably not going to hurt it, but it's not necessarily meeting those needs.
Yeah.
One
Yeah.
other
Absolutely.
one other thought comes to mind with that. With the comment on conventional grazing, commercial grazing, and targeted grazing is they can also be used in combination with one another.
Right.
Commercial grazing is common in the winter, in early spring months. Sometimes it extends a little bit later, but like Katie was saying earlier, the focus is not on vegetation management. It's on for commercial production. It's on livestock production. And so they're often leaving a lot of fuel, maybe more fuel than desirable in certain areas. And so that can be followed with targeted grazing. And it actually can enhance the impact of targeted grazing because some of the fuel has been removed, but not all of it. And so that means that at the critical time when you want lower fuel loads, a targeted grazing operation can come in and move and cover more ground more rapidly
Sure,
after
And I,
yeah,
you know,
maybe.
following commercial grazing.
yeah,
Yeah, maybe I misunderstood, but I guess in my example, I was kind of noting things that I don't think anybody's going to eat, right? And that's just where
right.
those other
Yeah,
tools
right, right.
have to be part of it, right? It's
Yep.
all those tools in the toolbox.
Yeah.
I want to acknowledge Martin's question because that's kind of the classic rancher question, right? One person's fall feed is another person's fuel load. And I think any of us that have run livestock commercially, especially through the drought, are really concerned about saving that winter feed. Um, at the ranch level, I think there's some opportunities to do some very site-specific targeted grazing to protect fall forage, to protect ranch infrastructure in a way that still maintains a fall graze for the commercial operation. So I think again, like you were suggesting, Morgan, that it's not either or, it's
Yep.
both and in lots of cases.
Yeah,
Yeah,
and
and I think
one
we were.
situation that comes to mind is grassland that's surrounding some housing development, and that might have commercial grazing, but yet it's sort of still high vegetation loads close to the homes, and so they bring in a targeted grazer to graze a band right around the homes. One example, very different than a forest environment.
Yeah, and I do think like it's again in those grassland environments, like you're talking about on like at a ranch scale, there can be that's where that strategic landscape, it's smaller scale. When I think of strategic landscape fuels management, I do tend to, because
Mhm.
of where I work, I'm thinking about those watershed scales, but I think you can think about different sort of pastures or areas where you're keeping that winter feed and where you're bringing it down.
Yeah, I think that's a great point of transition to our fun interactive group activity. So we wanted folks to have the opportunity to think through how you would do that initial like assessment of different fuels, kind of like what we're talking about in different landscapes. So for each image that you're about to see, it'd be really great to think, what fuels do you see? Do you think it's possible to graze here? What is the role of grazing potentially in this ecosystem? Maybe what other treatments could be used? And then also it'd be great for those of you in the audience that have grazed in these systems before, if you have any tips or challenges you want to share with the group. So this is our first image. If it gets to load. Okay, so the first one that you see is a young pine plantation, the mixed conifer area. So I think it's a small enough group where you could either type it in the chat, or if someone's feeling brave, you can unmute yourself and kind of talk us through your process of evaluating. Let me pull up the chat. So what fuels do you see in this system?
Remarkable self-control.
I can uh I can take a stab at
Yeah,
it.
go ahead.
So I'm seeing a lot of like these low shrubs
Hmm.
and obviously some taller trees. Just from the picture that I'm seeing,
Yeah.
I think you would need to cut some fence line ahead of you. But I think this is a situation in which some goats could probably come in and make a positive impact in terms of at least doing some of the understory work and maybe
Yeah.
doing a little bit of a browse line on some of those more mature trees. Depending on when you're grazing it, they're less interested in the conifers in the summer, but
Yeah.
that you might get a little bit more spacing between the sort of bottom ladder fuels and the ground.
Yeah, awesome. Thank you, Katie. That was great. Anyone else have any observations or experiences that they want to share?
I know
Yeah.
we graze in a similar situation to this, just it's a natural meadow um, mm, rangeland that we use. And my cows absolutely love manzanita in the summertime, and they will wipe out every leaf on a manzanita bush. And there is a little bit of that, it looks like, in the very front.
Yeah.
It's hard to tell if it's manzanita or if it's
Yeah, it
a
is
different type.
Manzanita
Yeah, so
and
they would do
Wildfire.
that.
Cool.
I don't know why they like it, but they do. They'll
Awesome.
eat it over grass.
Just to the point about fencing, this is similar to some country that we're using virtual fence with cattle in, which I like because you don't have to walk through the whitethorn to cut fence line. And I think we're going to be able to test whether we can get cows. Certainly, we'd get the cows to eat some of the herbaceous vegetation in a setting like this, but maybe we'd get some impact on the brush as well.
Any final observations or thoughts before we go to the next image?
If this was by my house, I'd probably want to take out a few of the trees too
Yes.
and
True.
be thinking about that woody debris.
Yeah.
I think there's a lot to be said with grazing, especially with grazing cattle too, for just the effect that the trampling down has and them just walking through even some of the woodier, thicker brush that they don't want to eat, just them walking through it and trampling it down creates a ton of space.
That's a good point, Allison.
And I think folks also use that for invasive species control, the trampling portion of it, right? So that's could be one of those win-wins depending on what you're dealing with.
Yeah. All right. We're going to go to the next example for the sake of time. Maybe this, I know this might look familiar for Allison. This is Hopland Rec up in Mendocino County, but the idea here is more oak woodland type. So, what kind of fuels do you see in this system? Do you think it's possible to graze here? Um, what do you think the role is of grazing as a fuel tool, reduction tool in these ecosystems?
If you all have a chance to watch some of the YouTube videos on the fire at Hopland, it's pretty instructive.
Yeah. Laura?
Hey guys, so I actually just kind of thought about this. Looking at this scenario, I would definitely say in terms of animals, more sheep than goats. But which got me thinking, is there any research or evidence that different breeds of goats and or sheep have different effects on landscapes?
So there is some work that was done at Utah State that is less breed specific and more how animals learn their forage preferences. Um, and what we know from that research is that they're just like we are, that they learn what to eat from their mother. And there's some evidence that they learn what to eat even in utero by what their mother is grazing while she's carrying them. Um, there's certainly some breed differences in terms of pygmy goats would not be something I'd put on 5 foot high deciduous ceanothus. But to my knowledge, and Morgan or Allison may know differently, but I don't know that there's as much research on breed differences as there is on how grazing and foraging behavior and preferences are determined.
I would just add that that's a great question for some of the livestock producers that we'll have as part of these some of these webinars. because a lot of livestock producers they develop preferences. You have some that say that last week I think Beth was saying that she really likes her Kiko goats because they do a better job than the Boer goats in brushy areas. And I've heard of other targeted grazers talk about how they really like Dorper sheep because they eat better than some of the wool sheep, more traditional wool sheep that they've run. So that's and they don't have to shear them. It's another um, benefit that they see. But I think asking questions like that to some of the livestock producers. I don't know of research on that topic, but I think there are a lot of developed preferences.
Ashley?
Yeah, thanks. I'm adding to that kind of question as we're developing our regional protocol. The grazer that we're going to be working with is specifically, so we're working on like what breeds and what type of ruminant, whether or not it's a sheep or a goat. And then there's also these questions about, the seasonal determination of where it works best to place what species, what time of year for the targeted fuel. So there's all these complexities. And our grazer just purchased, I am not a grazer. I am a wildfire mitigation practitioner. So I'll preface with that, but she just purchased a Navajo churro, a bunch of the ewes to put on this project and to bring them in earlier where we can't bring goats on early because we still have, freeze and they're very susceptible to the weather where these ewes are used to, this a totally different atmosphere. They can tolerate these cold temperatures and even some snow. So that's going to be really interesting for us to see when we're talking about what type of species, is there any specific species that are preferable for targeted grazing. So, but I really appreciate all the insight on this call from people that are doing grazing right now. I wanted to mention that too, because this is, super important to us. We had down in the lower, the grassy lands and the fine fuels, we have CAL FIRE coming up, and we're assisting with doing roadside prescribed fire to keep fire off of the roadway entering these grazing lands, that they're not only trying to protect a community right behind them, but at the same time, they're trying to preserve that grass for fuel for the commercial grazers. So it is so complex. So you guys are just, you're a wealth of information. And I want to just say thank you too. It's very helpful.
Thank you so much.
Katie, I put a couple pictures in the chat, and I just wanted to sort of add to this. The picture that you posted is almost exact. Well, it's the same type of woodland, but it's in almost exactly the same place. We had a really bad fire in 2018 that came through and burned pretty much everything you see in that picture. And it the part that looks like it was not burned had been grazed 3 months before. And the part that is black with all the trees dead hadn't been grazed in 5 years.
Wow.
So it's just like a super amazing example that we saw immediately firsthand of like, this is why we need to graze this area that is super, super high fire risk.
Yeah. Wow. Thank you for sharing those photos. I think for the sake of time, we're going to move to our last example. This is the last one. This is maybe more common to what we're seeing today in a lot of forested communities, unfortunately, but this is a conifer forest about 8 years post-fire. This is in the Angora fire footprint in the Tahoe area, if those of you are familiar. Anyone have any observations that they want to share or experiences grazing in post-fire ecosystems? Kristen, do you have any observations that you want to share with us?
Sure. Well, so obviously the grasses, could be a huge target. And but if you're looking in the background, we've got all these standing dead trees, and you look in the background, and that's really basically a contiguous shrub layer. And what we see pretty routinely in these high severity areas is that they recover similar to this, but particularly when they recover with that dense shrub component, and then all this dead wood falls, they tend to reburn at high severity. And the primary drivers there are the shrub layer and the woody fuel load. And so I think, it just like that may not, like their grazing may not be enough, right? And so that's just kind of thinking again about when, but there could be a component of it, particularly with the grassy herbaceous area, and then maybe breaking up some of the shrubs. But you look at the scale of that shrub layer, maybe not by grazers.
That's a really good point too, Kristen, that the herbaceous, if the herbaceous component is an invasive, if that were cheatgrass or medusa head or something like that, would change the fire frequency in that site, the right season and the right animal might help address that invasive. Maybe wouldn't address the other issues, but certainly could help address that herbaceous component.
One other thought comes to mind, and this is for you all again, being very ignorant on what the different animals like, but there's a lot of young aspen coming up, and we don't have a lot of aspen in general in the Sierra, and that might be something you think about protecting if if that's a component you really want in there. So this is kind of where all those different needs
Absolutely.
start to intersect.
Absolutely.
I
And
would
we
think they'd
find
be very yummy to some critters at least.
with aspens and willows, it seems to be very seasonal. They get sweeter when it gets colder, and so early season can be a time to graze without impacting the aspens and the willows.
Oh, I did not know
I've
that.
actually sampled willow aspen leaves myself, and they really do not taste good, just so you know.
Thank you. I was curious. So I think if folks don't have any other observations, we're about out of time tonight, actually. So an hour and a half really flew by. So thank you all for being engaged and joining us on this Tuesday evening. One out of many Tuesday evenings, from what I understand, will be spent with this short course. So I can stick around for a couple minutes if folks have questions, but thank you so much for joining us tonight. Thank you, Allison, Dan, and Morgan, for also lending your expertise through questions and follow-up. And thank you so much to Kristen Shive for leading part of this webinar and really stepping up and learning about targeted grazing for this. So thank you so much.